Welcome to another of our short webinars. This time it's about membrane keypads. My name is Thomas Lenner and I'm the team leader for our design and development team. For the next 20 minutes, I'll go through some of the most common design and construction options for membrane keypads. Please feel free to write your questions as we go along. We'll use the last 10 minutes or so to answer as many as possible. And we'll also share all incoming Q&As with all of you after the webinar. So, in the world of touch and digital interfaces, why are we still talking about membrane keypads? Well, membrane keypads still remain a strong and relevant solution when space and sealing and cost efficiency matters. They have a slim construction, all the way down to 1 millimeter. You can achieve good tactile feedback where the key actually clicks when you push it. And they also have endless graphic design options and the functional layers you can add to your keypad stacker. As you can see here, a membrane keypad is built up like a sandwich. And with this webinar, we want to give you a look at the possibilities you can choose between and the most relevant materials early in the development process. This might save you redesign, time spent on redesign later in the process. This webinar is also structured around these different layers. So first we'll have a look at the front layer, where we have different possibilities at the top of the keypad, such as the artwork, embossing, and coatings. Then we'll go through the click layer and see what options you have here. And on this layer, also look a bit at backlight integration, looking at here where you can integrate the backlighting and light guides and even diffuser films. And then we'll take a closer look at some of these advanced layers or advanced functional layers, such as ESD grids, anti-Newton ring layers, and so on. And last but not least, also look a bit about integration of displays directly into the membrane keypad sandwich, which we see more and more. But before jumping into these different layers, let's just briefly have a look at the fundamental technology behind membrane keypads, which is screen printing. Both the artwork, the conductive inks, and a lot of the other functional layers are all screen printed. Screen printing means that each color is a printing step and requires a separate stencil. So for example, if you want to do an artwork like this, you'll need 3 different prints. First the black, the colored windows, and then a lightproof white color on the backside. It also has a bit of limitation screen printing when it comes to artwork. So graphics like complex graphics like multicolor gradients, detailed shadows and highlights, and even photorealistic artwork with many colors. In this case, screen printing it becomes a bit more difficult, and it's more relevant to look at, for example, digital printing. Because digital printing doesn't require a screen or each color, it does it all in more or less one shot, meaning that the number of colors doesn't really matter. Therefore, most detailed artwork is made with digital printing today. This is also the printing technology we use for rapid prototyping and low quantity parts with many colors, for example. However, there are also some limitations with digital print. It's not as durable as screen printing inks. And also, as the digital ink still is a combination of small dots, it's not as light-proof compared to a solid screen printing ink. But this is where we have a strong opportunity of combining these 2 technologies. So for example, to print the complex artwork like this on the front side on the first print in digital, and then adding a light-proof color on the back side as shown on the video here. And both screen and digital inks can be both front side and back side printed. But the advantage of backside printing is, of course, that you have the ink on the backside of the material. So you see through the material and you have the ink protected on the backside. Now, let's have a look at the first layer, the top layer or the front layer, and see what we can do here. The most typical material used for this layer is polyester or polycarbonate. And we use a transparent material, and then we can apply different inks and colors and gloss and coatings to it. Here we have an example of a solid color, the black in this case, where the actual color is the same, but we used a lacquer to highlight and make the keys gloss, as you see here. So this makes this contrast between the matte and the gloss to enhance keys, for example. Can also just use it as a visual element as part of the design. As you see here, we have a solid red background color where we on top printed a lacquer also to make this visual element here to highlight some of the keys. And if you need backlight symbols, it's also possible to do color tinted symbols in your artwork with screen printing. And here you see an example where we actually combined both dead front and colored symbols. And in some cases, it could be a cost-efficient method to use, for example, in this case, white LEDs underneath, so you have the same color LED, and then make the color of the light in the screen printed logo, as you see here. So that in that case, you can do the customization on the front layer, but keep the electronics the same at your side. So that's a possibility. You can also apply what we call a dead front, where where either it can be symbols or artwork as shown here. And it means that we use a special printing technique to add a color to the front of the graphics that makes the graphics only appear when it's backlit. So you can keep a clear and simple interface and hide symbols or graphics until it's necessary for the user to see them. You've probably seen this in the dashboard of your car where the icons also are used with this dead front effect. And here you can see the customers also use it with colored LEDs and combined it with the dead front solution here. Colored display windows can also be part of the artwork or design. You can use them for aesthetic reasons, but they also can serve a practical function. In this case, it's used for enhancing the 7-segment display they have underneath. So you can add either a green or a burgundy in this case to change the color of the numbers you're seeing. And in this case, it creates a better contrast, so the numbers are more visible when the user is wearing a welding mask, for example. It's also possible to add embossings to the front layer. You can use it to enhance keys or areas of the surface. And we have here we have different embossing designs that can be used. I'll just show you some of the most commonly used that we use for customers. The first one is the one that's just a raised flat embossing. You can see it's more or less just taking a given surface like this, like a plateau, and just pressing it and then mechanically stressing it to make it raised like this. So here's an example where it's also used for a circular, where you can see the edge of the embossing is almost straight. You can also do a dome embossing, which is more or less the same principle, but instead of having these straight surfaces on the embossing, it's curved, so you get this more 3D effect, so a double curved surface. And it gives it a bit more snappy feedback when you click it. It actually has a small tactile feedback compared to the previous one I showed you. You can also use rim embossing like this, where it's the rim is used to enhance the contour of a key. So this is the key is actually still flat, but then you have the raised rim here to enhance the button. It can also be used in this case, where it's also a rim embossing, but in this case the customer had some issues with the alignment between the housing and the display that was mounted. We all know that it's hard to get a zero tolerance position between a display and a housing. So if we didn't have this embossing here, you would actually be able to see the small level difference between the display and the housing through the foil. So instead of having that challenge, they solved it by doing this rim embossing and made it part of the design. You can also use multi-level embossing, where you can do 2 different levels or even more embossings on a key. So here you can see in this case it's a dome embossing, where they did a dome like this, but then the symbols or the icons on the key also has the extra level. So it's actually makes it possible for the user to feel the shape of the icon of the button without actually looking at it. So this was just 4 of the most common embossing types that we use. Of course, they can be combined in different ways. We use both what we call heat and cold embossing. So heat is where we apply 80+ degrees to permanently deform a polyester material, for example, where the cold embossing is without heat, where it's just a mechanical stress that at a single press deforms the material. By using heat, you will get a more permanent deformation of the material and an embossing that remains longer. And as mentioned, we use both polycarbonate and polyester. Polycarbonate, when embossed, when you're using heat, it becomes very brittle or stiff when it's being embossed. So you actually have a slight a clear tactile feedback on a polycarbonate compared to a polyester that's a bit more soft, where you'll have a bit more soft and more flex in the material when you emboss it with heat. This also makes it, as a rule of thumb, that the polyester can actually withstand up to 5 million actuations, where polycarbonate is only up to 100K. And this might be okay for some applications if you don't need to push the buttons that many times, but normally we're talking a million activations when we're talking the demands for actuations. Of course, it's also a combination in our process between time and temperature. So the longer time you have it in the embossing tool, the higher and more permanent embossing you can have, and the higher temperature, the more permanent or deformed the material will also become. But of course, it's a very fine balance between these parameters. So we also have a rule of thumb saying that you should not make an embossing that's more than 2.5 times the thickness of the material you're embossing, because you'll simply stress it too much. So for example, if you have a 0.15 millimeter polyester, the embossing shouldn't be more than around 0.3. And again, when it comes to assembly, if we're just supplying a overlay with an embossing on it, and you have your own tactile key component or components underneath, it's very important for us to understand and have a dialogue about which tactile component. Because if you, for example, use a polycarbonate which has a small tactile feel in the actual embossing, you'll have the risk of first feeling the click from the polycarbonate, and then afterwards the click of the tactile key element, or the other way around. So first the tactile switch and then the embossing. And you don't want to have this multi-click and confusing the user if the key has actually been activated or not. So this is also very important to understand the combination and the assembly with the tactile key components. And talking about the click layer. In membrane keypads, we generally have 2 ways to achieve the click. Either by metal domes, as you see here, which has a very tactile and clear click, or we can also use polydomes, which is a solution where you actually emboss the materials here to make it like just shown previously, having the tactile feel in the actual embossing. Metal domes are used in many cases. It's almost standard, but in some cases it could be worth considering polydomes when you have requirements such as low click volume or something like that. But again, polydomes also they have the risk of losing tactility and embossing height over time, especially if exposed to many actuations at also higher temperatures, because it is an embossing. So the higher the temperature, the bigger the risk for the material to deform would be there. Yeah. Where the metal dome, that remains its tactility and can normally also withstand 1 million plus actuations. Yeah. You can also have a look at backlighting if you want to incorporate LEDs in your membrane switch keypad. And the most commonly challenged with backlight in membrane keypads is to achieve a good, even distributing light, because you normally only have a couple of millimeters of thickness. And we also say that there's like a rule of thumb that the longer the distance you have from the light source to the area you want to illuminate, the better. Because this distance allows the light to spread. But as I mentioned earlier, we have membrane keypads that are normally only 1 millimeter thick, so you don't have this distance to create the even distributing of light. We have different ways of diffusing or directing a light in a membrane keypad, which can be built into the sandwich. We can either use what we call a light guide film. We can also use a diffuser film, which is actually a film with some light shattering agent mixed into it that diffuses or enhances the light. Or we can even, by screen printing, also use a diffuser ink to enhance the light or to even diffuse it. Yeah. And we also know that silicon has very good diffusion and transportation of light. So it's also a possibility to actually incorporate small silicon bricks or layers into the keypad. And here you see a case where we actually used a light guide film to evenly distribute or spread the light over these icons. And we want to normally use as few LEDs as possible to make it even distribute the light. Of course, it's easy to make the light even if you just add a lot of LEDs, but this also has a cost impact and also a space limitation in some cases. And you can see here the light guide film is just added into the big sandwich of the membrane switch keypad here. So here it's not just about the light guide film, it's also a combination about the placement of the LEDs and the direction. So here we placed the LEDs in the top of the keypad due to limited space, and these are so-called side view LEDs, so they do not emit upwards, but they side emit the light. So we shine the LEDs emit into the edge of a polycarbonate material here, so directly into the edge. And then we added these lacquer dots on top, so you emit light into the edge, and then it transports the light, and then when it hits some of these dots, it changes direction and shines upwards. So there's been a lot of trial and errors for this specific part to get the illumination just right. And looking a bit at these functional layers, as we call them, it's also a possibility to incorporate these ESD layers, which provides an invisible shielding and protection. Yeah, and it can be integrated directly into the keypad, as you can see here, without actually adding too much to the thickness. In this case, the customer has incorporated a carbon mesh here, as you can see, to protect the circuitry here from ESD. And here the grid is actually grounded separately with a tail here. And that's because in some cases the grounding components or part or in the customer assembly might be placed away from the top surface where you most commonly have the ESD issues. So in this case, you can ground it another position or another place in the assembly at the customer. You can also use a silver mesh, as we've done here. You can see here the mesh is printed with silver, and we made these solid silver squares here. And then we added a conductive material on top with a conductive adhesive also. And then the customer has the grounding in their housing, their metal housing. So when the keypad is mounted directly onto the housing, this also functions as the connection point for the ESD. Also, when incorporating displays or other elements behind a printed window on a keypad, you might have issues with Newton rings. And here we also have the possibility of screen printing these small lacquer dots, just like the light guide film, on the backside of the window to create a small distance between the underlaying glass or display or whatever that could be in the assembly. And this is an easy and effective way that keeps the display clear. Of course, you will have these dots, but they create a small distance, so you don't have these Newton rings or rainbow effects or oil effects, as somebody also called them. And last but not least, as we also see more and more integration of these displays directly into the keypad. So here having the whole stack up, and then from the backside, we actually integrate this display. There's many technologies and methods of incorporating these and also choosing the right display, which is a whole webinar for itself. But in this case, you can also, most commonly, we use an OCA adhesive, so it's permanently with an optical clear adhesive mounted directly on the backside of the window of the keypad. So it's one finished assembly you receive with a tail for the keypad and a tail for the display to mount it. So you have a almost finalized HMI front with the display and keys and everything, and you only need to connect the tails. And even incorporating, and also as you see here, both a membrane keypad with a display and even on a plastic housing here, so it cannot be any more plug and play like that for an HMI solution. So looking a bit of running through this presentation and looking at some of the key considerations, you might consider something like this when you are designing your next keypad. Most commonly, where is the keypad used? And this affects what materials and coating and temperatures we'll use understanding, is it outdoor, is the moisture, and all of this can affect it. Now, how many actuations do we require? As mentioned, it might be okay to have few actuations. Sometimes we're talking millions, and this also affects the material we choose and the embossing and even the click component, where we also need to understand this in order to recommend the best solution. And what type of backlighting do you need? Is it night light? Is it a status icon besides a printed symbol, or is the whole symbol, does that need to be lit? Do you need colored LEDs, or do you want the color in the artwork? Do you want the late customization for the color of the light in the front layer or on the LEDs you use yourself? Also, do you want this dead front effect? Do you want all of the graphics to be visible for the user, or do you want it only to be visible when it's relevant? And again, where are the LEDs placed? Do we want to incorporate it in the membrane switch keypad? Is the LEDs on your own PCB? And then we have to consider the distance, as I talked about, and how we can incorporate this and integrate it. Do you need ESD protection? And then consider what is in your assembly, what possibilities are there to ground the ESD layer? Is it a separate area in the assembly or directly on the front housing? And also, do you plan to integrate a display in the keypad? It might be worth considering. Most normally the PCB can be part of the display can be part of the PCB, but it might be worth considering incorporating it directly into the keypad, so you don't have these issues with the Newton rings and all the other areas I mentioned about. So I think the most important message for you to remember is to specify the keypad as early as possible in your product development, considering these areas, and also to think about the assembly process and to simplify your number of components. So incorporate more, or use the possibility of combining more into the membrane switch keypad, so you don't have a lot of different either suppliers or layers of components you have to incorporate or integrate yourself. Because you can simplify your product design as well as your production process. So yeah, that's our message from here. So just a small teaser for some of the upcoming themes. As I mentioned, the light integrations with the light guides and the ESDs, but also combined with the display integration. What are the possibilities and focus points here for you? We'll have some more webinars next year where we'll cover some of these themes. So hoping to also see you there. Now I think it's time for some of the questions. Let's have a look and see what we got. I'll just go through the Q&A. Yes, there are some questions. Yes, it's recorded, and we'll share the webinar with you afterwards. And we have a question here from Helle answering, what is low quality? And I say it's not only the quantity that's affecting if you want to use digital printing or screen printing. It also depends very much on the type of artwork that needs to be printed and the requirements you have to it. But you can say, as a rule of thumb, the more colors you have and the fewer quantities you have of it, the more relevant it is to look at digital printing. But if you say that it needs to be used in a very rough environment, or you have requirements for that the ink should be light proof, then we might have to look at a combination or looking at screen printing instead. So it's not just the quantity that should be looked at here for choosing digital printing or screen printing, also all of the other parameters. And then we have a question here. Are dead fronts with color symbols clearly visible recommend for use in strong bright light daylight conditions? Yes, they are. Of course, it's especially when you're talking dead front. Normally, this has been used with a black surface and a black, like a tinted color. So you want a black and black. And of course, the more dead front, the less visible you want it to be, the less light would shine through. So this is always a balance, but there's also, of course, we can do adjustments to the translucency of the dead front ink being used, but it's also a combination of the LEDs you're using and how they are directed. But yes, for most of the customers that have used this dead front effect and also the colored symbols, these are also used in daylight conditions. So yes, that is possible. Another question here from if we have experience in using Braille. Yes, we do so. This is the same principle as the embossing I showed with the rim and everything. You just have small dots instead. You can either do it by embossing, depends on the requirements and the durability of it, but you can also use lacquers as the small dots I showed you. You can also print these brailles with lacquers on top, but that is a little less durable than if the material is embossed. Then we have a question about the finish diffusion options. As I mentioned, there's different ways of either diffusing or enhancing or transporting the light. But if we're just talking diffusion, then I think the thinnest option is, of course, the screen printing options. And this is where we can use a diffuser ink to print it. And that's only, let's say 10 microns thick, maybe 10 to 20 microns thick. And then if you go through, but of course, screen printing is the less efficient diffuser ink. Then you can go to a foil also, and I think they start around 50 microns or something, 15 to 100 microns. But we can share some more details if you're interested in what available materials and links we have. Then we have a question here about metal domes, if they're glued or soldered. They're actually, the metal domes, there are also soldable domes. It's not something we've done that much in yet, but there are available soldable domes for FR4 PCBAs. But normally we build up a memory switch keypad with a spacer, with a hole for the metal dome, and then we put a dome coverlay. So the dome is actually laying loose, you could say, but it has a dome retainer on top, keeping it in place. And a small cutout where it's like a pocket it's positioned in. And we have a question here about how far the LEDs can be placed from the area that needs to be lit when using light guide films. Oh yeah. Again, hard to answer as a rule of thumb, because there's, how big an area needs to be lit. What are the requirements for the brightness of the LEDs? But I can say if we're talking very long distance, so I think maybe above 5-10 centimeters or more like that, it might be worth looking at how you can use the plastic part or housing to either use light channels or using also injection mode in light guides, where you have like a transparent material, like a pipe you use, and then that transports the light. So in that case, but depending on the design and the actual application, I think that it's hard to answer overall. Then we have a question here about embossing that's up to 1 to 2 millimeters. Yes, we get requests for this. We normally say that the standard embossing height is between 0.3 to 0.5, and as mentioned, the material thickness is very dependent on how high an embossing you can get. So again, the rule of thumb, you shouldn't do an embossing that's more than 2.5 times the height of the material thickness, because then you'll actually stress the material too much. And this is all the recommendation from the material suppliers. But there are possibilities to add either resin or coatings on top to make it even more high if you want more height on the actual button, or doing something else. Or even look at silicon keypads if you're looking into really having a tactile feel and that 3D shape of a key. Yeah, then we also have a question here how we can smoothen these uneven mountain surfaces that are visible through the key panel, a joint interface between two surfaces. Yeah, and as mentioned, the most commonly, as we see where they use these frame or rim embossing, is where we have a edge between a cabinet and a display that's mounted, where the display either is too low, but most commonly it sticks a little bit up, and then you'll clearly see this unevenness through the keypad when it's mounted. And this is where we can either do an embossing with this rim embossing and make it part of the design, but you can even also just, as it is a sandwich, you can have the front layer, and then we can underneath build more thickness to it, and then just do the thickness that makes the same height as the uneven area between the two surfaces, and then do a small cutout here to actually uneven that. So build up on the back side of the keypad. That's also a possibility if you don't want this rim embossing visible on the front side. Yeah, I think we just have one more question, then the time is up. If it's more expensive than current implementation methods like using normal push buttons on PCBs, I would say yes. This is, for many years, has been the most cost-efficient solution for a keypad is this membrane switch keypads. So definitely a very cost-effective. But of course, it depends on if you have a lot of LEDs and a lot of I don't know, connectors and other components on it. Then it might be worth looking at a PCBA for these components. But again, if you have a simple keypad with a few lights and a few buttons, then definitely membrane switch keypads will be more competitive. Yeah, I think that's it. What can I have? We still have a few questions, but as mentioned, we'll make sure to share all of the Q&As with you afterwards. And then we'll answer you directly also the ones we didn't have time to answer. So thank you very much for joining. Again, always a pleasure to present, and nice with so many participants. Looking forward to seeing you again, hopefully. Have a great day.